we should have an idea that why are we studying open channel flow? What is the significant role of it in the GATE examination? This is a small topic. The thing is, you should be clear with the concepts, with the formulas. We'll start from the base and then we'll be proceeding it subsequently. Slope is horizontal like this. If this is your channel bed and this is a slope, then the flow profile of water will be different. If it goes at an inclination, the slope, like assume it as a mild, then the flow profile will be different. What I believe is, we as civil engineers, we are not interested in mugging up the things because civil is something which is related to our daily life. Hello everyone, welcome to GATE Academy Global. Myself Richa Gupta, and as you all know, we are here with this different new channel with the same institute so that the content could be delivered to you in English this time. Same feeling, same context and same concept as well. Fine. So here in this new channel, that is GATE Academy Global, I'll be dealing with you in the chapter, or you can say in the topic of open channel flow. So as I have told you earlier that this is basically an English channel, so all the things which I will be delivering, that will be in English language, so that the students who have problem with the Hindi language could have a better understanding of the given chapters or the given subjects. So in this open channel flow, it is an introductory video which I will be dealing with you today, so that you can get a clear concept what are the important topics or what are the overall topics which are necessary for the GATE examination. Fine. So here we are with these topics. I have written all the topics. We will be dealing with it step by step. I will be telling you what are the topics in which the questions have been asked and what are the topics which are although there in the open channel flow, but till now there haven't been any questions on this topic. But that doesn't mean in future also there won't be any questions on this topic. Fine. So as we proceed with this introductory lecture of the open channel flow, I'll try that we could cover maximum part of these, all the concepts, or we can say all the contents which I have written it here. But before going through that, we should have an idea that why are we studying open channel flow? What is the significant role of it in the GATE examination? So my dear students, I hope you already know that in GATE examination, open channel flow comes out to be around 2 to 4 marks. So if you take an average, it is of 3 marks. So you know that how much this 2 to 4 marks plays an important role, or you can say a significant role in your GATE examination. That is why, and this is a small topic, the thing is you should be clear with the concepts, with the formulas. Fine. So moving on to the first topic, that is introduction to OCF, that is the short form of our open channel flow. In that we will be dealing first the introduction part of the OCF, what does this open channel flow stands for, why we call a channel section and open channel flow sections. These are the simple concepts which you should learn. Like what I believe is, we as civil engineers, we are not interested in mugging up the things because civil is something which is related to our daily life. So seeing the things in practicality and implementing these things in our general life or in our daily life, you can say, will give you a more better understanding of the subject. Fine. So moving on to the first, as I told you, open channel flow introduction. Then why this open channel flow we study is different from the pipe flow. As you know that pipe flow you would have been studying, or you would have already studied in your fluid mechanics. So there generally you go through the pipe flow, conduit and the passage of it, head loss and all the pipe flows and all. These are the various concepts which you deal in your pipe flow. So when the flow is same, like open channel flow and pipe flow, although flow is taking place of a liquid, specifically of water, then why there is a need to study open channel flow as a separate topic as compared to your pipe flow? This contradictory thing, or you can say the difference between that, we will be also dealing. Fine. Then the types of open channel flow, because there couldn't be a static that only one type of channel flow is there. There are different variations you can say based on shape, based on construction, based on change in cross section and slope, and based on boundary characteristics. Like in boundary characteristics you have rigid boundary channels, you have mobile boundary channels. So I'll try that, as I told you earlier, that we'll try to cover maximum of the portion of open channel flow as much as possible, or I can say that what are the important topics which are there for GATE examination to the maximum possible extent I'll try to cover. Now moving on to the fourth one, that is the geometric parameters. See, there is geometric parameters like hydraulic depth, hydraulic radius, wetted area, wetted perimeters, depth of flow section, depth of flow. So what are these? What does this stands for? What does this indicates? Fine, it's as I told you earlier, better than mugging up, it's better that we should understand the denotions, fine, the derivations and the formulas, so that at the very last moment you won't get confused. After this, coming to the classification of open channel flow. Now how this introduction differs from your classification part. In classification we will be dealing with steady flow, unsteady flow, uniform flow, non-uniform flow. First their definitions, then their permutation and combinations. Moving on further, there will be classification of uniform flow and non-uniform flow, because in non-uniform flow there is further different classifications like gradually varied flow and rapidly varied flow. So here, while introduction part of OCF is concerned, simple definitions will be told to you, but after that, as we will be proceeding to the non-uniform flow, there we will be doing the detailed discussion on non-uniform flow. After that we will be going to the velocity distribution, or we can say that velocity distribution numericals. Simple numericals are there, that for shallow water what is the velocity, average velocity which you take, for deep waters what is the average velocity which is encountered. Then last one is your types of equations like continuity equations, energy equation, momentum equation. These are the equations which are there and which are used for the analysis, or you can say in the derivation of uniform as well as in the non-uniform flow. Fine. So this is the brief outlook of your introduction to OCF, or you can say these are the basic important topics which we have encountered in this first topic, that is introduction to OCF. Now moving on to the second topic, that is the uniform flow. Being in uniform flow, what does this uniform flow stands for? What does it tries to tell us? What does means when we say that the flow is uniform? What are the parameters which vary or which are constant? This should be clear to you. Then what are the features? When you can say a flow is uniform, what are the silent features of this uniform flow? Third will be your uniform flow equations. Like when you study anything, the first thing is that, like if I am studying uniform flow or if I am studying an open channel flow, the thing is I want to get a value. Like if this flow is uniform, I want to know the depth of the flow. If I want to design an open channel flow sections, I have to calculate the depth, I have to calculate the discharge. So for that all reasons, whenever any topic which we are studying in open channel flow, the thing which we are very much interested is the numerical value, is the quantity of flow, is the amount of flow, and for that reason we are doing mathematical calculations, derivations, so that at the end result we can get a numerical value for the designing purposes. So uniform flow equations, from that we can get the depth or we can design a section. After that we will be dealing with most economical channel sections. Economical channel sections, in that various shapes of channels are there, like rectangular, triangular, trapezoidal and circular as well. So we will try to cover maximum, as I told you earlier, it is not mandatory as I am saying that I will be covering all topics, but we will try to cover at the maximum possible extent. So in this most economical channel sections, why the channel is said to be most efficient or most economical, this query we will be dealing with. Why was there is a need to design a most efficient or economical channel sections? These all things also we will be dealing. Then the criteria for the most economical channel sections, how can we calculate the most economical rectangular channel sections, similarly triangular, similarly trapezoidal, these all will be seen. Then comes the shear stresses on the boundary of uniform flow. The expression for shear stress we will be also seeing. Fine. So these were the two topics initially. Now we will be moving to the third topic, that is energy depth relationship. This topic in particular is important as far as your GATE exams is concerned. I will try that we should solve GATE examinations questions as well, so that if you have any queries like in a derivation, that will be very much clear when we will be moving towards the numerical part. So in this, first, what does this energy depth relationship stands for? Its definition. Then we will be moving to what does this alternate depth is. Then subsequently we will be dealing with criteria for minimum specific energy and maximum discharge. This is also important as it will play an important role as far as your numerical point is concerned. Fine. Subsequently we will be dealing what are the features of critical flow. Basically what is this critical flow and supercritical and subcriticals. These terminologies, those who have already studied open channel flow, they know it, and those students who haven't studied or haven't touched open channel flow, my dear students, you don't have to worry. In introduction to open channel flow, I will be telling you what is this critical flow, subcritical flow and supercritical flow. Fine. After that we will be moving here. It is not like suddenly I will give you a term which you don't have any knowledge about it and we will be start discussing. We will start from the base and then we will be proceeding it subsequently. Fine. So features of critical flow, then the relation between critical depth and minimum specific energy. After that, an important topic which is very important is your channel transition. For this topic, your concept should be crystal clear, because I believe that instead of mugging up these things, if your concept is clear, you would be able to solve any sorts of questions which will be encountered in this GATE 2020. Fine, even in further GATE examinations as well. So this channel transition, there are two subparts. Transition means what? Whenever there is a change, either be a sudden change or an abrupt change or a gradual change, that is a transition. Fine, the transition in sudden manner or in gradually if it is varying, that is transition. So the transition can be of two types. First is your flow through hump and the second one is your width contraction. So we will be dealing this into two subcategories more, like flow through hump is for supercritical flow also and for subcritical flow also. Similarly, width contraction happens both for subcritical flow and supercritical flow. Fine. So this is an important topic. Questions have already been asked from this topic in the previous GATE examinations. Fine. So these was regarding the discussion of topic 3, that is energy depth relationship. Now moving to the fourth topic, that is non-uniform flow, or I can say that it is gradually varied flow, because in non-uniform flow you have two types of flow. One is your gradually varied flow and the second one is your rapidly varied flow. So in the gradually varied flow, the starting will be from the introduction. Second is the salient features, like when we use gradually varied flow, where you have seen this in practical. Fine. So and what are the features, what are the assumptions which you take while calculating the gradually varied flow formulas, or you can say expressions. Fine. Then important part is classification of flow profiles. In this classification part, basically mild slope, steep slope is there, horizontal slope, adverse slope, critical slopes. These are the various types of slope. But how they flow, basically if your flow is something like this, it is horizontal, then it goes slightly tilted. Fine, the slope is mild, then it goes suddenly like this, so the slope becomes steep. fine, and this is like horizontal. So what are the variations in the flow type? Because it is a common sense, like if your slope is horizontal like this, if this is your channel bed and this is a slope, then the flow profile of water will be different. If it goes at an inclination, the slope, like it assume it as a mild, then the flow profile will be different. Similarly for steep slope. So we will be knowing that how the flow profile varies. Fine, step by step how the flow profile varies for the different types of slopes. Then moving on to the flow profile diagrams also, we will be drawing the diagrams for the each and every types of slope. Fifth one is your break-in grade. Just giving you a slight introduction of this break-in grade. As I told you, there are different types of slopes which are existing. They don't exist like in singular form. Singular form means if a channel section is there, it is not necessary that the channel section's initial slope was mild. So after the end of the channel section, the slope will be mild. Generally, it doesn't happen. Now, then what does happens? In break-in grade, what we do is, there are different types of slopes which are there simultaneously, or it will occur one by one. That is, a mild slope is there which is followed by steep slope. After steep slope, there will be horizontal slope. Then what will be the flow profile? Either the flow will grow upstairs or downstream. What are the various permutation that can happen? These all are encountered in your break-in grade. Then the last one in gradually varied flow is GVF. In short form, we say gradually varied flow as GVF. So gradually varied flow profile computations. In this, although there are many methods for computation like direct step method, integration method. So we will be dealing the important method in which questions have been asked and which is important. Fine. So these are the 6 topics which can be encountered, or say I found it to be very useful in if we classify a separate topic in open channel flow as gradually varied flow. After this, now moving to the 5th topic, that is non-uniform flow, but here we will be dealing with rapidly varied flow. Now first, what is this rapidly varied flow? Already we would have been discussed in the introductory part, but just a brief introductions. What are the characteristics of the rapidly varied flow? What is hydraulic jump? In this hydraulic jump, why this hydraulic jump is necessary? This is also important. So these are the topics which we will be dealing. After hydraulic jump, we will be dealing with jump in non-rectangular channel sections, because if you see in GATE examinations, generally questions of rapidly varied flow, because many expressions are there in rapidly varied flow. So generally what happens is, the numerical based questions, they comes in rectangular channel, means if the channel sections is rectangular, so that formulas can be put directly and values can be obtained. But what happens is, sometimes if you see like in the coming years GATE examinations, if there will be some permutations and like if in place of rectangular channel sections, other sorts of channel sections like triangular, trapezoidal is asked, then there is necessary that we should be able to calculate the jump in non-rectangular channel sections. Fine, because what happens is, student basically study it for rectangular channel sections and they assume that this formula is valid for any types of channel sections. No, my dear students, it does not happen like the manner which you think, because I have seen many students, any type of channel sections, if you consider, they will apply the same Bollinger's momentum equation. No, it does not happen. There is some simple concepts which if you will study, then it will be easy that if be it any type of channel sections which is given, you will be able to calculate it. Fine. Then the 5th one is your energy dissipation. Basically hydraulic jump is used for energy dissipation only. So how you can calculate the dissipated energy, the energy loss exclusively for rectangular channel sections, these all are encountered in your rapidly varied flow. After this, we have the classification of jumps based on Froude number, that is whether it is an undular jump, weak jump, oscillating jump, steady jump, strong jump or choppy jump. So these are the various types of jumps which are there if we do classification of jump. Basically all the topics which I told you, they are encountered in your non-uniform flow specifically rapidly varied flow. Last, moving on to the topic is the surges. What are these surges? Their basic definition. How do we do what are the types of surges? Fine. How the types of surges vary, their various examples, like we have positive surges, we have negative surges. So what are the examples of it? We should know it. Moving on to the next is the analysis of surges. Like as I told you earlier, we civil engineers, we should know the whole mechanism, whole phenomena, how it is occurring. According to that, we should be able to calculate the numerical expression and particularly the numerical values for designing purposes. Therefore, we will be dealing with analysis of surges, how you can analyze the surges. Then the last one is your celerity. Fine. So, this topic, that it is not so much important. Till now date, you can say not many questions have been, hardly 1 or 2 questions may be around, not many, almost negligible questions have been asked on this topic. Fine. Celerity based questions, sometimes it does, this is important, celerity topic, and analysis of surges also we will be studying. I am not telling that till now if it haven't been asked, it couldn't be asked further, because probability of questions from any topic or any chapter is there in equal amount. But we will be focusing on these topics as well in which questions haven't been asked, as well as on the topics in which questions have already been asked, and good questions can be framed as well on this topic. Fine. So, here I discussed regarding each and everything regarding the open channel flow. I think that is more than sufficient if we are interested in studying open channel flow. So, all the students, basically to the students who are very much comfortable in English, we are here with you, and I'll be try, as I told you earlier as well, that I'll try that maximum possible content should be delivered to you, and maximum possible topics along with the subject, we can say along with the numericals which are asked in the GATE examinations could be covered. Fine. So, I hope you enjoyed this introductory video of open channel flow. I will be waiting for you all, and we will be meeting in the next lecture with the particular topic of the open channel flow which we will be dealing. So, till then you keep practicing, keep learning. Thank you.